All right, hello everybody. Welcome to the midterm key. I'm going to start off with number 1. So it's asking for the domain of this function right here. So I know a few things. First of all, this is in the denominator, so it can't be equal to 0. And it's also under a radical. So that means that this thing under the radical can never be negative. So that means that 2 minus x, the thing under the radical, can't be equal to 0, and it has to be greater than 0. So I'm just going to set it greater than 0. And now I solve. So I'll subtract 2 from both sides, and I get negative x is greater than negative 2, divide by negative 1, divide by negative 1. When I do that, I have to flip the sign, and I get x has to be less than 2. That would be answer choice number 2. You could also solve that by graphing. You can go in here, and you can say negative, what is it? I'll do a fraction. It's 3 over the square root of 2 minus x, and I'll graph it. So I'm seeing all of these numbers less than 2 seem to work, but not the number is greater than 2. That is my cutoff point right here where x equals 2. All right, on to number 2. So for number 2, we are saying that this thing is being multiplied by its conjugate. So I'm going to say negative 3 minus 2i is being multiplied by its conjugate, negative 3 plus 2i. So I want to find the result. I could use my calculator and just plug it in right there, but I'm going to do it by hand. Negative 3 times negative 3 is 9. Negative 3 times 2i is negative 6i. Negative 3 times negative 2i is positive 6i. Negative 2i times negative 2i is negative 4i squared. I know that I squared is equal to negative 1. So when I cancel out these middle terms here, which they will, I'm going to rewrite this as 9 minus 4 times negative 1, which will be the same thing as 9 minus negative 4, which is the same thing as 9 plus 4, which is 13. And you could have, again, just plugged all of that into your calculator. Number 3, it's asking us to solve by completing the square. So the first thing I'm going to do is get everything on one side. So it's going to be x squared minus 12x plus 7 equals 0. I'm going to subtract my c term. X squared minus 12x equals negative 7. And then I'm going to divide my b term by 2. And I'm going to square that. So that is going to be equal to negative 12 divided by 2 is negative 6. Squared is 36. So I am adding 36 to both sides. Negative 7 plus 36 is going to be equal to 29. And then this is going to factor into x minus 6 squared. And I see that is right here. X minus 6 squared equals 29. Number 4, it's saying that f of x is equal to this and g of x is equal to this. What is f of g of x? So that means I am taking f of x and I'm going to plug g of x, which is x plus 5, into it. Now I'm going to expand it. To square something is to multiply it by itself. I'm going to go ahead and distribute this out. So negative 3x minus 15 plus 1. Let's FOIL now. So that'll be 2x squared plus 10x plus 25 minus 3x minus 15 plus 1. Distribute 2x squared plus 20x plus 50 minus 3x minus 15 plus 1. Combine my like terms. I've got a 2x and a negative 3x. That gives me 2x squared plus 17x. Then I have a 50 and a negative 15, which would be 35 plus 1 is 36. And that is answer choice number 1. Number 5. It's asking me which expression is equivalent to this. So I'm going to draw a fraction bar. I'm seeing I've got x to the negative 1, so that's going to get kicked to the bottom. Y squared is going to stay on top. X squared is going to stay on bottom. Y to the 4th is going to get kicked to the top. This becomes y to the 6th over x to the 3rd power. Answer choice number 4. All right, which function could be this graph? So I'm going to do it by the roots. So I know I've got one root here, so this is going to be an x minus 1 because my root is at positive 1. Here I've got a root at negative 2, so this is going to be like an x plus 2. And here I have a root right here at negative 4, so this is going to be an x plus 4. Now I'm seeing all of these seem to have my x plus 2 terms, so this can't be right because x minus 2 isn't one of my factors. So it's either 1 or 4. So if x plus 2, I just put that out front, and then I multiply x plus 4 times x minus 1, and I distribute that, I would get x squared plus 3x minus 4, x plus 2. Answer choice number 1. I could, of course, graph that to check it. So if I go in here, clear it out, and I do x plus 2, parentheses, x squared plus 3x minus 4. It's always good to check your work. I should see a graph with the roots in the right place. And yeah, sure enough, I do. Graphed it. Done. Just to be totally clear, I'll drag both of those screens over so you guys can see what I did. Alrighty. On to number 7. Alright, so I've got the cube root of 27 times the cube root of a to the 3rd times the 4th root of 16 times the 4th root of b to the 8th. The cube root of 27 is 3, because 3 times 3 times 3 is 27. The cube root of a cubed, well, those cancel, so I'm left with an a. The cube root of 14 is, or excuse me, the cube root of 16 is 2, because 2 times 2 times 2 times 2 is 16. And then this is going to be b squared. So 3 times 2 gives me 6, and then I have a and b squared. So I've got 6ab squared. Number 7 is 1. So I made a mistake on that last one. Little hiccup, so I'm doing it again. I've got 3/4 times the square root of negative 80. So first of all, I see I've got a negative under a radical. That's going to turn into an I. So I know I've got to have an I in it, which means answer choices 3 and 4 can't be right. Let's simplify the radical now. So the square root of negative 80. Well, first of all, I'm going to break that into 3 pieces. I'm going to break out the square root of negative 1, which is eventually going to turn into an I. And then I'm going to break it up into the square root of 16 times the square root of 5. So the square root of 16 is 4. The square root of 5 is just going to stay under the radical because I can't simplify that any further. And then I'm going to take all of this and I'm going to bring down the 3/4. Those are going to get multiplied. So it's going to be 3/4 times 4i radical 5. 3/4 times 4, so I'm just going to go ahead and do that by hand because I don't want to use a calculator. Times 4 over 1 is going to be equal to 12 over 4, which is equal to 3. So that means my final answer is going to be 3i radical 5, which is right here. Yay! Miss Varghese has joined us. She's going to do the next one.
Hey.
Hey, hey.
I'm a little shorter, so I need to bring that down. But anyway, so we see that f of x is equal to x minus 7 over 2, and it's asking us for the value of f of the inverse. So f negative 1 means that it's the inverse of f of 3. So conceptually, I know that we have a function, and we have the inverse of it, so they're going to undo each other. So your answer is just going to be 3. But we can also work that out just to make sure that it's good. So we know that we take the 3 and we plug it into the inverse of f. So we're going to find the inverse of this. So inverse means that you take f of x, which is y, is equal to x minus 7 over 2. You take x and y and you switch it. So it's going to be x is equal to y minus 7 over 2. And we're going to get that y by itself by multiplying by 2 on both sides. So we're going to go multiply by 2. We're going to multiply this side by 2. That's going to allow us to cancel these out. And so we get 2x is equal to y minus 7, and we add 7 to both sides, so we get 2x plus 7 is equal to y. So there's the inverse. So what we're going to do is we're going to take the 3, and we're doing f of 3. And so wherever we're seeing an x, we're plugging in the 3 in there. So we have 2 times 3 plus 7, and that gives us 6 plus 7, which is equal to 13. So that's not our final answer, right? Because then we got to take that 13. So all of this right now is 13, and we got to plug that back into f. So we're doing f of, and we're taking the previous answer, which is 13, and plugging it in. So we're doing f of 13. So here's our f value, right? So we're doing 13 minus 7 divided by 2, and we have to see if we get 3 back. So 13 minus 7 is equal to 6, and 6 divided by 2 is indeed 3. So 3 is our final answer.
So many ways to do these problems. Sure, I'll do the next one. Let's go. It says, given the functions f of x, or excuse me, yeah, f of x is the table here. That's f of x. I see it. I've got g of x, which is this function here, and h of x, which is my graph. It's going to ask me to compare them. It says, the correct list of functions ordered from greatest to least by average rate of change. So I know that's the same thing as slope. Over the interval from 0 to 3 is what? So again, I'm going from 0 to 3. The easiest one to do that for is probably my table, because I've got the points right in front of me. So my first point at 0 is the point 0, 1. And then my other point is 3, 7. So I can find the average rate of change by using slope formula. So that will be y2 minus y1 over x2 minus x1. The change in y over the change in x. So that's going to be 7 minus 1 over 3 minus 0, which is going to be equal to 7 minus 1, which is 6 over 3. So the average rate of change for f of x is 2. For g of x, I'm going to go ahead, I'm feeling lazy, I'm going to plug it into my calculator and check my table there so I can have basically the exact same thing I had before. So I'll go to my calculator, I'm going to go to my y equals screen, and I'm going to plug it in. X squared minus 2x going to my table. And I'm going to take this, and I am going to use average rate of change formula again. So that is going to be from the point, well, 3, 3, that's one of the points I care about, to the point 0, 0. So that will be the change in y, so 3 minus 0, over the change in x, 3 minus 0. That's going to be equal to 3 over 3, which is equal to 1. So the rate of change for g of x is equal to 1. That is a poorly drawn 1. I'm going to just do that again because that's just nasty. So that's slower. Now I'm going to do h of x. So I'm going to get coordinates from the graph. So this is the point 0, 2. And then when x is equal to 3, y is equal to 9. So this is going to be the point 3, 9. I'll use slope formula again. So 9 minus 2 over 3 minus 0 gives me 7 over 3, which is equal to 2.5. That's 2.5. I could have used my calculator to do that. And that means my greatest rate of change is going to be h of x. So I'm just going to write it from, it says greatest to least. So I'm going to do h of x first. Then after that comes f of x.
7 divided by 3 is 2.33.
Oh, oops. Miss Fergus just corrected me. Yeah, that was crazy. 7 divided by 2 is 3.5. Hubris. 7 divided by 3 is 2.33. So that doesn't actually change the ordering, but it is important to correct that. Thank you, Miss Fergus. All right, so f of x comes afterwards because f of x, the average rate of change is 2. So f of x will be next. And then finally, we'll close off with g of x because that had an average rate of change of 1. So that means the answer choice is going to be h of x, 4. Then f of x, then g of x, which is answer choice number 4. Yay! Number 11.
Okay, here's a doozy. So we're going to take this, and there's a general rule that you can make, but I'm looking at it and I'm seeing like there's remainders of 5, a 37, a 151. So it looks like one of the answers are going to be like either between 1 and 2. and I'm looking at 6x to the third divided by 2x, and it looks like it's going to be 3x squared. So it looks like the answer choice is going to be 1, but I'm going to go ahead and verify that that's true. So I'm going to go ahead and just divide this out. So my denominator is my divisor. That's what I'm going to put on the outside, and all of this is going to be the number that goes on the inside.
Is that called a dividend? What is that called?
Dividend. That's
It's
what
a
I'm
dividend?
dividing. Yep. 17x squared plus 10x plus 2. So the most common mistake that I see is people like write it wrong. So I just want to make sure that that's correct. So it looks good. So now I go 2x. So I look at 2x and I look at 6x cubed, and I see that 2x goes into 6x cubed 3x times. So I'm going to take that and put that above
3x squared times.
And then when I go ahead and I check it, I see that 3x times 2x is only 6x squared. So this one is a little bit different because now I have to the third power, so I have to put 3x squared. So now if I go ahead and I verify and I do distributive property, 3x squared times 2x is 6x cubed. So that works out now. 3x squared times 3 is 9x squared. Next step is I'm going to go ahead and subtract. So after I multiply, I subtract. So when I subtract, I change my sign. So that's going to be negative. That's going to be negative. I usually circle it. And then this is going to change into addition. These cancel each other out, and I'm left with 17 minus 9, which is equal to 6x squared. After I subtract, I have to bring down.
Isn't it 8?
Oh, good catch. 8. So 8x squared. Good catch. So 8x squared plus 10x. And then 2x goes into 8x squared 4x times. So I'm just going to go ahead and put 4x. And 4x times 2x is 8x squared. 4x times 3 is 12x. And then I'm going to go ahead and subtract that and do the same thing. I'm going to change the sign. So that's negative, that changes into a plus. So these are going to cancel out as per usual. And then 10 minus 12 gives us negative 2x. And the last term to bring down is at positive 2. And then lastly, I'm going to go, hey, 2x goes into negative 2x, negative 1 times. And I have 1 times 2x gives me negative 2x, and negative 1 times 3 gives me negative 3. I'm going to change my signs, and I see that these cancel out, and I'm left with a remainder of 5, which was my guess all along.
Woo!
So I see that my remainder is 5, and my divisor is 2x plus 3. So this right here winds up actually being the correct answer.
Good reasoning. All right, so for number 12, it's asking for solutions to an equation. It looks like it's going to be a quadratic equation because I have an x squared term. So these look like they come from quadratic formula. I'm going to get everything on one side so I can use it. So I'm going to move this 6x, the negative 6x, and the 20. So I'm adding 6x to both sides. I'm going to subtract 20 from both sides. And I get negative 1/2 x squared plus 6x minus 20 equals 0. To use my quadratic formula, I'm just going to note my a term, my b term, and my c term. And my a term is negative 1/2, my b term is 6, and my c term is negative 20. So it's going to be the opposite of my b term, plus or minus the square root of b squared. So that's 6 squared minus 4 times my a term, which is negative 1/2, times my c term, which is negative 20, all over 2a. So 2 times negative 1/2. Alrighty. So I'm going to go ahead and use my calculator because I'm feeling lazy. And I'm going to plug in everything under my radical sign. I'm not going to put the radical in there because if there's an I, it's going to give me an error. Hey, don't want that. So 6 squared minus 4 times negative 1/2 times negative 20. And that gives me a negative 4 under my radical. So I've got negative 6 plus or minus the square root of negative 4. 2 times 1/2 is 1. A positive times negative is a negative, so that's all going to be over negative 1. I know that the square root of 4 is equal to 2i, so I've got negative 6 plus or minus 2i all over negative 1. So this is going to be equal to negative 6 divided by negative 1 gives me a positive 6. 2i divided by negative 1 gives me a negative 2i, so it'll be 6 plus or minus negative 2i, which is just the same thing as 6 plus or minus 2i since I've got the positive and the negative thing. So that's going to be answer choice number 3.
Alrighty, so for this one, what we're going to do is we are going to get the denominators to be the same. So right now there is no denominator here, so I'm going to put a 1, which means that I need to multiply this by x plus 7. So here I see an x plus 7, but over here I do not. So I want to multiply this by x plus 7, but I can't just do it to the denominator, I have to do it to the numerator as well. So I multiply this by x plus 7. Over here, I want to multiply this by x and an x plus 7, because here my denominator is 1, so I want to do the same thing to the bottom. And over here, I see that I only have an x plus 7, so what's missing is an x, so I want to multiply this whole thing by x. That allows me to, once the denominators are the same, I'm going to cancel all of these out. And I have to do distributive property here, so I get 3x times x gives me 3x squared. X times 25 gives me 25x. I have minus, so I have negative 5x because negative 5 times x is negative 5x.
Don't forget to write your x there. Don't forget to write your x after the 25.
25x. Yep.
Cool.
And then, so it's negative 5x times x, which gives me negative 5x squared. And negative 5x times positive 7 gives me negative 35x is equal to, and I want to do distributive property here, so I get 3x plus 21.
Nice.
Now I want to combine like terms, so I have 3x squared minus 5x squared gives me negative 2x squared. I have 25 minus 35x gives me negative 10x. And I want to bring these over, well, I can set this equal to 3x plus 21, so I don't confuse anybody. And I want to move everything to one side, so I get negative 2x squared minus 13x minus 21 equals 0. And then I can just do a quadratic formula. Yeah, AC method is a little crazy, but why don't we try AC method? So I see negative, 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 so the most common sense thing I could do right now is divide everything by negative 1. So that allows me to like flip the sign, so I get this to be positive 2x squared. So I get 2x squared plus 13x plus 21 is equal to 0. I want to multiply 21 times 2. That gives me 42. And I'm looking for two numbers that multiply to give me 42 and add to give me 13. So
7 and 6.
7 and 6 work. So I have positive 7 and positive 6. So since this is called AC method, my A and my C do not change. So I do plus 21. And my B term gets broken down into positive 6x and positive 7x. I decided to put the 2 and the 6 together instead of the 2 and the 7 just because they have common factors that are obvious, and 7 and 21 also have common factors that are obvious, and it doesn't matter where I put it. Now when I split it down the middle, I factor out the left, and I'm left with x plus 3, and I can do distributive property to check, so that works out. Over here I see that there's a 7 that's the greatest common factor, and so when I do that I get x plus 3 as well, so we're golden, right? So because they match, I take that x plus 3 and I factor it out, and I'm left with 2x plus 7. Close it, put an equal sign, so I'm going to take this and put x plus 3 equals 0. So we've done this in class enough that I think I can skip that step, so x is equal to negative 3. So if I look over here, that can't be it, that can't be it, so it has to be one of these two. I subtract 7, divide by 2, so I get x is equal to negative 7 halves. So the answer has to be choice 4. Oh, and then I have to take my answers and plug it back in.
Good
That's
idea.
what we just learned. So I see that there's denominators here. So if I take the negative 3 and I plug it in, negative 3 plus 7 does not give me a 0. Negative 3 over here doesn't give me a 0. Negative 3 plugged in here doesn't give me a 0. If I take negative 7 halves and I plug it in, I'll see that I don't get a 0 as well. So both solutions actually do work.
Good call. All right, number 14. So it's giving me 2 points of an exponential function. It's asking me for the value of b. So I know one point is x value of 3, y value of 17. What am I doing? Y value of 17. Try that again. The other one, I've got x value of 7, y value of 3,156. And I have a tool on my calculator to help me out with that. So I'm going to do an exponential regression to find the equation. going to stat edit. I'm going to plug these points into my calculator. So 3 is one value of x, 7 is the other value of x, 17 is one value of y, 3,156 is the other value of y. Stat calc exponential regression, L1 and L2, good. And here we have it. So the value of b looks like it is about 3.69, which is answer choice number 3. Yeah. Number 15.
Okay, so over here, we're noticing that we have an exponential growth formula. And I know this because my rate is bigger than 1. So if I take a look at this real quick, I see that my growth, if I keep looking at it, it says that T represents the number of years since 2,500 fish were first measured. And we want to know which of the following represents the percent of the population will grow in a decade. So I know that since T is time, what I'm going to do first is do 1.025, and I'm going to raise it to the 10th power. So let's see what I'm going to take my calculator, and I'm going to clear that, and I'm going to do 1.025 raised to the 10th power, because T again is time, and that's years. So I get 1.28 something, something, something. I'm going to go back over here, and I have 1.2800, what was it? 844. Blah, blah, blah. So since I know that this is going to be, I'm looking for the percent, I know that this is going to be how much bigger this number is than 1. So I'm going to subtract 1 from it to find out what my percent is. So this clearly gives me like 0.28008 something, how many. And then I know if I'm going to go from decimal to a percent, I want to move the decimal 2 places to the right. So I'm going to go boom, boom. And that gives me about 28%. So my answer choice is 3.
Very nice. All right, number 16. It is asking us for f of 30. The f of 37. So first of all, it's saying that my first term is negative 18. So the first term is negative 18. My common difference is 7. So I'm always adding 7. And it wants me to know what the 37th term is going to be. So I'm going to use a formula for this. I don't feel like doing the whole thing. So that means I've got to find my reference sheet. I think I have it open still. So I've got it here, and I'm looking for a future term of an arithmetic sequence. So that is right here. There's the bell. Go home, children. Go home. All right. So the first thing I need with this future term of an arithmetic sequence is n. So I know that I'm looking for my 37th term, so n is 37. Then I need my common difference, which is 7. My common difference is 7.
How do you know that, Mr. Asher?
I know that because we are always taking our previous term and we are adding 7 to it. Then I need my a1, my first term. So I know my first term is going to be negative 18. So I can just plug it all in. So I can say a of 37, my 37th term, is equal to a1, which is negative 18, plus the number of terms, which is 37, minus 1, times my common difference. Negative 18 plus, and yes, I'm actually about to plug 37 minus 1 into a calculator. It's embarrassing. Times 7, and that gives me 234. So I'm just going to drag that in there for you guys. You don't need to worry about this top part. But there it is right there. So it's about 234, exactly 234 for my 37th term. Maybe we'll do like 2 more or something? I'll do 1, you'll do 1?
Sure.
Okay.
So over here we see that we're looking for the rule, but since it's multiple choice, I can use process of elimination to see which one is it by looking at the ones that are not it. So the number at the bottom tells me where I start. So I'm going to start with 3. So 3 minus 1 is equal to 2. On the bottom, I'm going to do 3 again. So 3 plus 6 is equal to 9. So far right now, it looks like 2/9 is a solution. So this could possibly be it, but I can't just test the first term. I want to take my next number up from 3, which is 4, and plug it back in. So 4 minus 1 is equal to 3. And 4 plus 6 is equal to 10. That's not what I have. So I see that choice number 1 does not work. If I plug this in right here, I see that 3 minus 1 is equal to 2. And on the bottom, I see that it's 3 squared, which is 9, plus 1 is 10. So I have 2 over 10, boom, automatically doesn't work. This one right here, I take my 2 and I plug it in. So I have 2 over 2 plus 1, which is 3, and 3 squared is equal to 9, so I have 2 over 9. My next number up from 2 is 3, so I do 3 over 3 plus 1 is 4, 4 squared is 16. Hey, that looks like it's going to be a winner. And then I want to check my last term. So my last term is 6, so I'm going to do 6 over. So far right now the top is golden. I'm going to take 6 and plug it in here. 6 plus 1 is 7, and 7 squared is 49. So it does look like 3 is my answer, and if I check 4, I'll see that it does not work.
All right, last one. So it's asking for this trinomial
Last one
written
for
as a product. For now. Yeah, no, don't get your hopes up. We're not done with this yet. All right, so I see, wow, it looks like I don't have a GCF here because that's an even number, that's an odd number, that's an even number. I think 53 is probably prime. I can't think of it on my times table anywhere. So I'm just going to have to use AC method on this thing. Looks like it's going to be a bit of a doozy. Or I could use, I could FOIL each of these. I'm going to use AC method because I think you guys need to practice that. But yes, you could absolutely FOIL these and just match up your answers. You could also graph this, find the roots, and work backwards. You have many options, but let's go ahead and use AC method. So 12 times 20 gives me 240 and 53. So I'm looking for two numbers that multiply to 240 and add to 53. They've both got to be positive. I'm thinking 48 plus 5 gives me 53. 48 times 5, it feels like it's going to work. Yeah, it does. Okay, 48 and 5. So I've got 12x squared plus 48x. That's a 4. Plus 5x plus 20. Split it down the middle, factor by grouping. 12x comes out of here, so this gives me x plus 4. Then a positive 5 comes out of here, and I have x plus 4. So that means one factor is 12x plus 5, and the other one is x plus 4. All right, we're going to take a break for the day. We'll be back. You won't even miss us. Okay, here's question 19. I am back from the comforts of my apartment, and I'm going to get started. So here we go. Question 19. It asks for the solution set. So the solutions to this equation. So right now I'm noticing it's already factored and it said equals 0. So that means I'm going to take each factor. Actually, I'll do it down here where I have more space. And I'm going to set each factor equal to 0. So when I solve this, I divide both sides by 2. And I get x equals 0. There's one solution. So this and this are out because 0 is not part of those solution sets. Here, I add 3 to both sides, and I get x equals 3. And then here, I'm going to subtract 1. I get 4x equals negative 1. Divide by 4. I get x equals negative 1 over 4. So that means I have answer choice number 1 is the correct answer. Moving along. Number 20 says which number line best represents the solution set of the inequality. So the first thing I'm going to do is factor it and set it equal to 0. I want to find the zeros before I do anything else. So I need to find two numbers that add to 3 and multiply to negative 10. So that looks like it is going to be a positive 5 and a negative 2, which means my two solutions are x equals negative 5 and x equals positive 2. So I'll put those on a number line. Negative 5 and 2. And it's a less than, so I'm almost certain I'm going to be shading in the middle. But just to be sure, well, they're going to be open circles because it's just a less than sign. I'm going to test a point. So I will test the point 0. So if I were to test the point 0, I would have 0 squared plus 3 times 0 minus 10 is less than 0. So all of this is going to be 0. And this is true. So that means I am going to shade in the middle, in between the zeros, not on the outsides, because 0 is right here in the middle. So that means that this is out because it's shading on the outside. This is out because it has the wrong zeros. And here we go. Answer choice number 3 is correct. On to number 21. All right. Number 21 tells me I need to factor completely. I've got a bunch of, well, I've got a trinomial. So I've got 12x to the fourth plus 10x squared minus 12x squared. And because it is a trinomial, I'm going to look for greatest common factor before I do anything else. And I see that a 2x squared goes into everything. If I factor that out, this will leave me with 6x squared plus 5x minus 6. No GCF anymore. If I distribute to check, that gives me 12x to the fourth plus 10x to the third. Oh, yeah, this is the third power. There. Okay, good. 12x to the third minus 12x squared. 10x to the third minus 12x squared. We're good. Okay. So anyways, these two multiply together. I'm going to do AC method. That gives me a negative 36. This is going to be a 5. So that'll be a positive 9 and a negative 4. Add to 5, multiply to negative 36. So I get 2x squared. I'm going to split everything apart. So I've got a 6x squared plus 9x minus 4x minus 6. Split that down the middle. GCF here is going to be 3x, which leaves me with 2x plus 3. Here it's going to be a negative 2, which leaves me with 2x plus 3. The 2x squared comes down from here. And then I'm going to wind up with one factor as 3x minus 2, and the other one is going to be 2x plus 3. And that looks like 3x minus 2, 2x plus 3, and 2x squared. That's answer choice number 4. All right, number 22. It's asking me about log t. So that means I am logging both sides. So I've got log t equals log of 10x squared over y. Now I'm going to expand the log because that's what it looks like happened here. So I see, first of all, that I can split this up into log of 10x squared, so that'll be 1 log, minus log of y, because the division is going to become subtraction. Then I notice that there's multiplication inside of this log, so that means that I can split the log apart into log of 10 plus log of x squared minus log of y. Now, I know log of 10 is equal to 1 because there's a base 10 here, and 10 to the first power gives me 10. So log of 10 equals 1. You could also plug that into your calculator. Then I also know that this can get kicked to the front because there's an exponent. So I'm going to rewrite this as 1 plus 2 log of x minus log of y. So 1 plus 2 log of x minus log of y. Number 22 is answer choice number 1. Number 23. All right, so it says to the nearest hundredth, the value that solves this equation is what? So I've got the x and the exponent, so I'm going to log both sides to get it out. Now, this thing in the exponent is going to get kicked to the front, so I get x minus 4 times log of 5 equals log of 275. Now I can divide both sides by log 5. And I get x minus 4 equals, that's a 4, just to be clear. Those cancel. Log 275 over log 5. Then I'm going to add 4 to both sides. And that's my answer, right here. I'm going to plug it into a calculator and let that do the work for me. So if I open up my calculator, and I just let it do the work for me here, I'm going to get log 275, close my parentheses, over log 5, close my parentheses, plus 4, and it gives me this. So I'm just going to put that down there, and that approximately equals 7.49, 7 and 49 hundredths. For number 24, it says which equation has an imaginary solution of 5 minus 3i. So imaginary solutions mean it's going to look something like this, right? There aren't going to be any roots at all. So I'm going to go back and figure out which of these have no roots, because if they have roots, they can't be right. They don't have imaginary solutions if they have roots. So I'm going to graph the first equation. So x squared plus 10x minus 34. So if I look at the graph, here it comes. Oh, hey. And this one has a root. So that is out. Next up, x squared minus 5x minus 34. Ha. And this one also has two roots that I can see, so that one is also out because it's got roots. Now I'm down to these next two. I don't know which one is right, so I'm going to go ahead and actually solve. I'm going to use the quadratic formula. So I'll take the first one, and I will do the opposite of b plus or minus the square root of, oh, I actually didn't even check to see if it has roots or not. I should show you guys that. So x squared minus 10x plus 34. Yep. So sure enough, this one's looking much more promising, right? This one here has imaginary roots, clearly. And so now I'll just continue this. So this was b squared minus 4 times my a term times my c term all over 2a. And this is looking promising because 2 times 1 is 2. I'll just go ahead and write that. Well, I'll just remember that that's 2. And 10 divided by 2 is going to give me a 5, which is what I wanted. So let's just take a look here. I don't want to do the square root. I'm just going to do it all at once. So negative 10 squared minus 4 times 1 times 34 gives me, yes, that's going to work, 10 plus or minus the square root of negative 36 all over 2 is equal to 10 plus or minus 6i over 2. And when I divide, I will get 10 divided by 2, which is 5 plus or minus 3i for answer choice number 3, which means that it is our correct answer. All right, onwards. Number 25. Can this mathematical rule be proved for all real numbers? So the first thing I know is I just need to see if it's an identity. Because if it's an identity, then it's true for all real numbers. So x plus y squared means I'm taking x plus y and I'm multiplying it by itself. And when I do that, I get x squared plus xy plus yx or xy plus y squared. Squared plus 2xy plus y squared. And then I combine my like terms and I get x squared plus 2xy, because xy plus another xy gives me 2xy's, plus y squared. And that equals x squared plus 2xy plus y squared. And sure enough, that is an identity. So this side is the same as this side, therefore it is an identity. I'm going to go ahead and type that out. This equation is an identity, so it is true for all real numbers. Great. Now I'm supposed to factor completely. I'm guessing it's probably AC method. I noticed there's a GCF of x, so I'm going to factor that out first. So I get 8x squared minus 10x plus 3. Then I can go ahead and factor it. So 8 times 3 is 24, and negative 10. So I'm looking for two numbers that add to negative 10 and multiply to positive 24. So they both have to be negative, because that's the only way they can add to a negative and multiply to a positive. And things that multiply to 6, okay, 6 times 4. Those multiply to 24, and they will add to 10. So then I can split this. I can say 8x squared minus 6x minus 4x plus 3. Split this down the middle and factor. So I'm going to get a 2x getting factored out here, which leaves me with 4x minus 3. And then I factor out a negative 1, which leaves me with 4x minus 3. And that is my trinomial, factored completely. 2x minus 1, 4x minus 3. It doesn't ask for solutions, so I'm stopping. Number 27. It says use an appropriate procedure to show that this is a factor of that. Explain your answer. So there are two ways I could do this, just right off the top. I could do long division, or I could do remainder theorem. For the remainder theorem, I want to see if this is a factor of this, so that means I need to plug in a positive 4. So plug 4 into f of x. So I would find f of 4. And if the remainder is 0, then it goes in evenly. So f of 4 equals 2 times 4 cubed minus 5 times 4 squared minus 11 times 4 minus 4. A lot of 4's there. So then that is going to be, I don't feel like bringing out my calculator here, so 2 parentheses 4 times 4 is 16 times 4 is 64 minus 5 times 4 squared is 16 minus 11 times 4 is 44 minus 4. 2 times 64 is 128. 5 times 16 is 80 minus 44 minus 4. 128 minus 80 is going to be 48 minus 44 minus 4, and that will give me 0. So sure enough, by the remainder theorem, the remainder is 0, so x minus 4 is a function of f of x. That will be my remainder theorem explanation. All right, next up. Oops, redo. Just trying to get this to fit. Formatting is always such a pain with these things. All right, now I'm going to do it with long division too, because I know some of you are going to attempt that, and I want you to be able to see where you went wrong if you made a mistake. Or if you want to learn it this way, you can learn it here. So 2x cubed minus 5x squared minus 11x minus 4. All right. X goes into 2x cubed, 2x squared times. Oops, and because that's 2x squared, I want to make sure I'm writing that on top of the x squareds. So 2x squared. 2x squared times x gives me 2x cubed. 2x squared times negative 4 gives me negative 8x squared. I subtract, so those cancel. Negative 5 minus negative 8, well, that's like adding 8. So then this gives me a positive 3x squared, bring down the negative 11x. Now, x goes into 3x squared, positive 3x times. Then I multiply. 3x times negative 4 gives me negative 12x. Those cancel. It's like I'm subtracting a negative, so that's like adding. And this just gives me an x. Bring down the negative 4, and then that goes in one time. X minus 4 times 1 gives me x minus 4. So when I subtract, everything cancels and I am left with 0. So either way, the remainder is 0. So, gosh, I just realized I wrote that wrong. So it's not a function of f of x, it's a factor of f of x. This is why you check your work, and we're good. All right, number 28. Given this function, it says to graph this function here and indicate all the transformations. So first, I'm going to note the transformations. First, parentheses first, there is a shift. So it shifted 1 unit, and then I'm adding 1 inside of parentheses, which means I'm going to the left. Next up, I see I've got that negative sign in front, which means it's going to be reflected over the x-axis. And then the third transformation is it's getting shifted up 2 units. All right, so those are my 3 transformations. Now I am going to do it. So I'm going to take this point, this point, this point, and this point, and I'm going to transform them. I'll use a different color. So I want to shift them 1 unit to the left, reflect it over the x-axis, and go up 2 units. 1 to the left, reflect it. So this is going down 1, 2, 3, 4, 5, which means I go down 1, 2, 3, 4, 5, and then go up 2 units. Same here. 1 left, over the x-axis, up 2 units. 1 left, over the x-axis, 1, 2, 3, up 2 units. All right, and that should do it. So there is my new function. I'm going to connect the dots using a red line. That connects to that, that connects to that, and that connects to that one. Now I'm double checking myself to make sure it looks good based on what I did before. And yes, I agree. All right, looks great. On to number 29. So for number 29, it's asking me to state the domain. Apparently I already did this one, so I'm going to erase it and do it again for you guys, just so you can see my thinking. The thing about a log is this thing here, the thing inside of the parentheses, always has to be greater than 0. And the reason why is because whenever I have a log, it's always set up like this, right? We've got log base 2 of x minus 4 equals y. This is the same thing if I were to do the circle of logs as 2 to the y equals x minus 4. Now, whenever I raise 2 to an exponent, I'm going to either get like a number that's larger than 2. So if I like square 2, I would get 4. If I raise it to third or fourth or fifth power, I'm going to be getting a larger and larger and larger number. Or if I were to take 2 and raise it to a negative exponent, that would be like 1 over 2, right? That would be like 2 to the negative 1. Or 2 to the negative 2 would be 1 over 2 squared, which is 1/4. But in any case, I can never actually reach 0. So that means that this thing here is always positive. Must be positive, must be greater than 0. So I am literally going to say x minus 4 has to be greater than 0. I'll add 4 to both sides, and I get x has to be greater than 4. That is my domain. On to number 30. I have to determine if x minus 1 is a factor of h of x, which is graphed right there. So I'm going to use my roots and turn them into factors. So this is a root at positive 2, so this is a factor of x minus 2. This is a root at negative 1, so there's going to be a factor of x plus 1. And then here is a root at negative 2, so that's going to be a factor of x plus 2. So I'm going to justify my answer. I know that x plus 1 is a factor of h of x, because h of x has a root at x equals negative 1. Therefore, by the zero product rule, it must have a factor of x plus 1. And that's about as clear as I can explain it. Right? If I have a factor of x plus 1, then I'm going to have a root at x equals -1. That's how it works. All right. I have to explain if this is even, odd, or neither. So even functions means that the end behavior is going in the same direction, right? So this is not even. That's not what we have. And an odd function means it's going in opposite directions. So it's going this way and this way, so it is indeed an odd function. This is odd. 32, I have to solve the following equation and express my answer in terms of e. So the first thing I'm going to do is add 5 to both sides and solve this. So I get 2 times the natural log of x plus 3 equals 3 plus 5, which is 8. Then I divide both sides by 2, and I get the natural log, because that cancels with that, of x plus 3 equals 4. Then I'm going to rewrite this in terms of e. So this is the same thing as log base e. And I'm going to do the circle of log to rearrange this. So I get e to the 4th power equals x plus 3. I'm going to subtract 3 from both sides to get x by itself, and I get x equals e to the 4th minus 3. Final answer in terms of e. Next. Okay, I've got a colony of bacteria growing exponentially, and the table shows the data collected daily. It is asking me to do an exponential regression equation. So I am going to go ahead and pull up my calculator. I'm going to stat, I'm going to go to edit, and I am going to put in these points. 1, 2, 3, 4, 5, 6, and 0. Then 200, 425, 570, 800, 1035, 1650, and 2600. Now I'm going to double check because I always make a mistake somewhere. 200, 425, 570, 800, 1035, 1650, 2600, 6, 5, 4, 3, 2, 1, 0. Actually looks okay. I'm going to go to stat, I'm going to go calc, I'm going to run an exponential regression. And here it is. I'm going to drag it over here, make sure it looks right based on what I've done before. Yep, alright, doesn't look like I made any errors when I did that. So I need to round each one to the nearest hundredth, which is 2 decimal points. So I'm rounding to this one right here. Look afterward, there's a 1 there. And then I'm rounding right here, look after there's a 0. So both of these are going to just stay as they are. I don't need to round them up. So my A term is going to be 239.21. My B term is going to be 1.48. And this will be raised to the x power because this is an exponential equation. And there is my equation. I suppose I should probably say y equals all of this because it is an equation. Alright, I'm solving for all values of x. First thing, I want to factor this. I'm noticing I have a trinomial, and I know this can factor into x minus 4 and x plus 3, because 4 plus 3 is -1, and 4 times 3 is -12. Alright, that's convenient. So now I'm noticing I've got denominators that do not match each other, and I want them to. So this has x minus 4, x plus 3, this has x plus 3, and this is x minus 4. So this thing is missing the x plus 3 that the other ones have, and this one is missing the x minus 4 that the other ones have. And whatever I do to the denominator, I have to do to the numerator. So I have to multiply this by x plus 3 on top and bottom, and I need to multiply this by x minus 4 on top and bottom. Other thing I'm noticing is I'm subtracting here, and subtracting is the same thing as adding a negative. I'm just doing this to clearly illustrate that there's this negative in front of the 1, so when I distribute, I'm going to have to multiply both the x and the -4 by -1. Now, I'm going to distribute. I get x squared plus 3x. Then I distribute the -1. I get -x plus 4 equals 28. I can cross out my denominators because they all match now and just not worry about them at all. Okay, I want to combine like terms, get everything on one side and factor. So I'll do that both in one step just to make it a little bit quicker and easier. Those cancel, so I'm left with a 0 on this side. Then x squared, 3x minus x gives me a positive 2x. 4 minus 28 is -24. two numbers that add to 2 and multiply to negative 24. I think a 6 and a 4. So I'm going to have an x plus 6 and x minus 4 equals 0. All of a sudden I just had some alarms start going off in my head because I'm noticing I've got an x minus 4 down here and an x plus 3 down here. So that means that there are going to be some undefined points in this function. So I know that x can never be equal to 4 because that would make this undefined. This fraction right here would become undefined. And I know x can never be equal to negative 3 because that would make this thing undefined. So x cannot equal negative 3 or negative 4. Now, when I solve this using the zero product law, I'll get x equals negative 6 and x equals 4. And like I just said, x can never be equal to 4, so this is an extraneous solution. That means my only solution is x equals negative 6. On to number 35. It says use the properties of rational exponents to determine the value of y for the equation. So I'm going to rewrite everything as a rational exponent, or an exponent with a fraction. Here I have a root of 3 and an exponent of 8, divided by x to the 4 times 1/3, which is the 4/3 power. Then I know anytime I do division, it's like subtracting my exponents. So this is like x to the 8 over 3 minus 4 over 3 equals x to the y power. 8/3 minus 4/3 is common denominator, so I can just write that. And then 8 minus 4 gives me 4. So if x to the 4/3 is equal to x to the y, that means y must be equal to 4/3. So it's kind of a confusing way to write it. So I'm going to actually write this out. Y equals 4 over 3. All right, number 36, I have to solve for p algebraically. Things I'm noticing. I've got a logarithmic equation. I've got two logs on the same side with subtraction in the middle. So I can condense those into division. Then I'm going to have to do circle of log to get this thing into an exponential form so I can solve it. So I've got log base 16. My numerator is going to be p squared minus p plus 4. My denominator is going to be 2p plus 11. And all of this is going to be equal to 3/4. Now I can do circle of log. So I get 16 to the 3/4 power is equal to p squared minus p plus 4 over 2p plus 11. 16 to the 3/4 power, I'm going to use my calculator to figure out. So I've got to reopen my calculator because I just closed it. It's frozen on me. And I get, again, 16 to the 3/4. 8. 16 to the 3/4 is 8. Great. So 8 equals all of this. P squared minus p plus 4 over 2p plus 11. Now, I want to get p by itself ultimately, so I'm going to put this 8 over 1 and I'm going to cross multiply. So 1 times all of this, well, anything times 1 is just itself, so that gives me p squared minus p plus 4 equals, and then I'm going to take 8 and multiply it by 2p plus 11. I'm going to show this more clearly. So 8 times 2p gives me 16p, 8 times 11 gives me a positive 88. I'm going to subtract 88 from both sides to get everything on one side so I can factor. I'm going to subtract 16p from both sides. And I get p squared minus 17p minus 4 minus 88 is a negative 84 equals 0. Numbers that add to 17 and multiply to 84. Okay, so 84 is divisible by 4. I know, so yeah, that's 21. So 21 minus, 21 and 4. 21 times 4 gives me 84, and then 21 minus 4 gives me 17. So I can play around with the signs and make this work. So I'm going to have a p minus 21 and a p plus 4. That works. So then I get p equals 21 and p equals negative 4. Alright, so I know for a fact that whenever I have these logarithmic equations, I often wind up with extraneous solutions. So I want to make sure that these solutions are not actually extraneous. And I'm going to do this by graphing. So I'm going to go in here, I'm going to do log base right there, base 16. I'm going to do x squared instead of p. So x squared minus x plus 4. All of this minus 2, excuse me, I need to do another log. Log base 16 again, and then this is 2x plus 11, and I want to know when it is equal to 3 over 4. I'm going to make sure that's right. 16x squared minus x plus 4 minus log base 16 of 2x plus 11. Looks good. So I'm going to go to my table, and I'm going to make sure that this works. So first I'm going to check negative 4, and sure enough, they are equal at negative 4. So there's one part where it's true. Then I'm going to check positive 21 and make sure I don't have any errors or anything like that. That'll make this untrue and extraneous. And sure enough, 21 is also a perfectly legitimate solution. So these are both very real solutions to this equation. Alright, on to number 37. So for 37, I see I'm going to need my reference sheet. So I'm not sure if I have this up or not. I'm going to pause and grab a reference sheet because I see I need the sum of the geometric series formula. So I will be right back with that. Alright, so I pulled up my reference sheet here, and I see that this is the formula that is for the sum of a geometric series. So I'm just going to grab that and paste it right into my slides for you guys. So let's make this a little smaller so we can manage it. Alright, so the sum of a series. The first thing I need to know is my first term, and then I need to know my common ratio. So if it is growing by 3.2%, it says she starts off making $45,000, so that means my initial value is going to be $45,000. And then my common ratio is what I multiply by to get to the next number. So if she's getting a 3.2% raise, in order to make something grow by 3%, I need to multiply it by 1.03, and it's 3.2, so it's 1.032. This is my common ratio. Now, if I want to find this equation, I just have to substitute both of those in. So I'm going to do 45,000 minus 45,000 times my common ratio raised to the n power over 1 minus my common ratio. And that is what I needed to write the formula after n years. We don't know what n is in this case. Now it says, how much does she earn in her 20th year as an architect? So to find earnings in a specific year, I need to use the future term of a geometric series formula. So I want to find what a of 20 is. So I'm just going to drag that down and put it in place so we can work with it. So I know that my n in this case equals 20. And I know my common ratio from the last problem is 1.032. So, first of all, also A1 is 45,000. I know that as well. So that means that A of 20 equals 45,000, the starting salary, 1.032 to the n minus 1 power. So that means this is going to be raised to the 19th power. All right. I almost made a mistake there, and I put 20, but it's always the n minus 1. So 20 minus 1 is 19. Cool. So let's take a look at that. I've got 45,000. And there is the final salary. So that means after 20 years, she is going to be making about $81,000 in her 20th year. If you were to write this out as a sum of money, I suppose you would do $81,870.37. How much does she earn in her first 20 years? So this means I'm looking for the sum, which means I'm going to take this formula right here. Whew, I didn't mean to do that. I just want to grab this formula. So I don't know if that worked or not. It did work. Now I want to ungrab this, and I'm actually just going to copy it, paste it, and drag it right down here. But instead of n now, I know that I am going to have the first 20 years, so n will be 20. All right, now I'm just going to enter this in here. So 45,000 minus 45,000 times 1.032, all raised to the 20th power, because in this case it's raised to the n, and then 1 minus 1.032. I have an overflow error, and that is because I accidentally messed something up there. So that should be, I'm going to insert a parenthesis, and then there. That should do it. I don't know why I have an unmatched parenthesis there. I hope that's not a problem. Oh no, there it is. Okay. So there we have it. I'm going to make sure this looks okay, and then copy down the answer. So 45,000 minus 45,000, parentheses 1.032 to the 20th power, over 1 minus 1.032. And it looks like a reasonable estimate for someone's earnings over the course of 20 years. Because it's money, I'm going to round to the nearest penny. And it looks like she is earning approximately, or perhaps exactly, $1,234,069.49. Whew, it's a lot of money. Well, that's question number 37, and I hope that this midterm went really well for all of you guys. Talk to you later.